Hello everyone, today we are going to discuss the design of a cloud-based file storage service like Dropbox or Google Drive. So if an interviewer asks you to design a file storage service, whether it is Google Drive or Microsoft OneDrive or Dropbox, the design will almost be same. And of course, the design is always based on the requirements that you will discuss with the interviewer during the interview. So let's first discuss those requirements. Before going into the requirement collection phase, you need to understand one thing about the file storage service system design. This interview question is a very tricky question. There are so many different things which an interviewer can ask you during this interview question. If you haven't watched my previous mock system design interview video on designing Dropbox service, you should watch the video. The link to the video you can find here, and you will understand that this interview question is very tricky. An interviewer can actually go in much depth if he wants to, if he asks this question. And that is why you need to give due importance to this interview question, and you should prepare well for this question. And unfortunately, all the other online sources that are available right now, they don't go in much detail in the design of a Dropbox service. They just discuss the design at a very high level, and that's it. But that is not enough, especially if you are targeting L5 or L6 levels in Facebook, Google, etc. So let's first discuss the functional requirement. The very first functional requirement is the user needs an account in order to use the file sharing service. So an account. And what it also means is that we can have two types of users. We can have free users and we can have premium users, where we can assume that the free users are using our service in a limited capacity. For example, they might have a limited storage available as compared to the storage space that is available for the premium users. Similarly, the network bandwidth that we provide to the free users might be way less than the network bandwidth that we provide to the premium users. The second requirement is that the user can have multiple devices. And now what he can do is that he can actually specify a root folder in any device, and whatever files and folders he create in that root folder, that is get replicated to all the other user devices. Right now we are assuming that the maximum file size that we are going to support is 1 GB. Another very important requirement that the interviewer can ask you to design is that a user should be able to share files and folders with other users. So file folder sharing. So by default, the original owner of the files and folders, he has read-write access, but when a user is sharing file or folders with other users, he can either provide them read-write access, or he can also just provide them read-only access. So the original owner of a file or a folder has read-write access to it, and he can also the one who can actually share the files and folder with other users. A user can only share a file or folder which he owns. A user cannot share a file or folder with other users if he is not the original owner of that file or folder. So the owner has full access, and what full access means, he can read-write the files, he can read the files, he can share the files, while the other users can have just read-write or read-only. So other users can have either read-write or just read-only access to the files and folders. The other requirement is the system should support storing files and folders up to a certain limit only. And once a user has reached his file storage limit, the system should not allow any other writes. Another requirement is the system should allow offline creation of files or offline update or deletion of files and folders. So what it means that while a device is offline, the user can go and either modify a file or delete a file or even create a new file. And when that device gets connected with the Dropbox service, then all those changes get replicated to all the other devices for the user. There can be some other extended functional requirements. For example, the system should allow multiple versions of a file, and the user should be able to recover the file to a previous version if he wants. However, this requirement is a very tricky requirement because it imposes several design constraints and questions as follow. The very first question that comes to mind is that how the versioning should be performed. Whether it is from an update to another update, or it's a daily snapshot of all the updates. Another question is how it will affect the files and folders which are shared among various users. If a user with read-write access decided to revert some changes of a file, how those changes will be replicated to the devices of all the other users. Also, the third question is how it will affect the storage capacity of a user. Whether the total space consumed by each version or snapshot is counted towards the total space consumed by the user or not. And what should be done once a user has reached its limit in that case? Should we start dropping older versions, or should we just stop creating new versions, etc.? So you should clarify these type of requirements and constraints with the interviewer during the interview, and then based on what you decide with the interviewer, you need to design the system accordingly. Another extended requirement is the system should be able to keep track of all the analytics related to the storage and network consumption. Also, one other extended requirement is, which actually comes into picture when you start allowing sharing of files and folders among users, that what will happen if two users try to update a same file, and if a conflict arises because of that, how you will resolve that conflict. Another important requirement is data security. The risk of data read during transmission can be mitigated through encryption technology. Encryption in transit protects data as it is being transmitted to and from the device to the cloud or vice versa. Encryption at rest protects data that is stored in the cloud service. Another requirement is to provide search facility so that a user can actually able to go and search his files and folders. So these are the different functional requirements. Now we are going to discuss some non-functional requirements of the system. I think by now, if you guys have seen all my previous videos, you must already know now which are the important non-functional requirements that we need to discuss. So the very first non-functional requirement is the system needs to be highly available and fault tolerant. The second non-functional requirement is the system should be highly scalable, and it should scale with increasing load or increasing users and data. The third requirement is the file synchronization should use minimal network bandwidth. The fourth non-functional requirement is that the file transfer should happen with minimal latency. These two non-functional requirements about the file synchronization requiring minimal bandwidth and minimal latency are very important, because due to these two requirements, we will decide to upload every file by first dividing it into small segments or chunks. This will enable us to only upload or download modified chunks of a file, and also if uploading or downloading of a chunk failed, we only need to retry the upload or download of that particular chunk instead of retrying the upload or download of the complete file. The fifth non-functional requirement is the Dropbox service guarantee ACID requirements for the files that are stored with the Dropbox service. ACID stands for atomicity, consistency, isolation, and durability. Let's suppose in one of your device, a file was changed from one version to another, and those changes get replicated to all the other devices. So now if you go to the second device, in the second device, the file which was changed in the first device is now getting all the changes, which will move it from the first version to the second version. And it's totally possible that in order to move from the first version to the second version, there might be multiple chunks that got modified. And so all those chunks get uploaded separately, and then on the second device they gets downloaded separately. But now the issue is that if you just apply one chunk at a time, it's totally possible that the user will see the file on that device in a transient state, where he will see the first chunk get applied, then the second chunk get applied, and so on. However, it will break our atomicity requirement. The atomicity means either all or nothing. So the user should not see all the transient changes while we are moving a file from one version to another version. So how we will achieve this atomicity requirement in the Dropbox service is that in our client-side Dropbox application, we will first apply all the changes to a temporary file. And that file could be stored in a temporary folder or maybe in the same folder with a different name, and that file could be hidden from the user. And once all the changes are applied to the file, then we can actually use an atomic file operation like link or rename to switch the temporary file with the original file atomically. However, if you check all the other online sources, none of them actually discuss about this thing. The C in the ACID requirement stands for consistency. Consistency in the ACID properties means that data moves from one correct state to another correct state, with no possibility that the readers could view different values that don't make sense together. For example, if a user has deleted a file in one device, then other users or devices should not see that file getting partially deleted first. This is an inconsistent state that would cause errors if someone tried to read or write the partial file. This is different from the replication consistency, which we are going to discuss later, where an update happens in a device but takes some time to actually get replicated to other devices. I in ACID properties stand for isolation. It means transactions that are happening concurrently will not affect each other. In case of Dropbox service, it means two things. First of all, any updates to different files are totally isolated from each other. They do not affect each other. Second is related to update of a single file in multiple devices. If a file gets updated in multiple devices at the same time, then one of them will have to wait for other write to complete first. However, this is really hard to enforce in a true distributed system. Consider updates that are happening to a single file on two different devices, and both of those devices are actually offline. So you see, if we have one requirement where we say that we would allow updates on files offline, then having this isolation requirement where we actually try to make sure that updates don't happen to the same file at the same time on a device actually impose a lot of constraints on our system, because now our system has to handle this case also where updates can happen to a file and both the on two different devices, and those two devices can be offline. And now when those two devices gets online, then those updates will flow to each other and it could cause conflicts, and then we need some way to resolve those conflicts, which is a very hard problem. Now D in ACID properties is durability. It means that once a change has been made and uploaded, then it will not be lost. For example, if a file has been created to a device and synced to the remote file storage, then that file should not be lost. This does not imply that another operation later on will not modify or delete the file. It just means that the changes are available to the next operation to work with as necessary. It also implies that any writes that happen to a Dropbox service should be replicated to multiple data centers, even across continents, to make sure that any large-scale disaster, for example earthquake or flooding or fire, that can wipe out the entire data center does not cause data loss. Here I like to add one more thing. If you check other online sources, you will see that they discuss that using a relational database actually provide this ACID requirements. And if you are using NoSQL database, then of course then you have to provide these ACID requirements programmatically. But this is where these other resources are wrong. Just using a relational database will not provide the ACID requirements, because we need to understand what the ACID means in case of Dropbox service. If the A in the atomicity means that when a file changes from one version to another version on a device, the user should not see any transient state, then just having a relational database in the backend will not be enough. So this is I like to point out here, that don't just assume and don't mention this to the interviewer that okay, if you just go with the relational database, it is going to fulfill the ACID requirements, because that will be wrong. And then the interviewer will ask you, what does the ACID requirement means? And the same thing you can see in the previous mock interview, where the candidate, when discussed the ACID requirements, I specifically asked him, what does the ACID means in case of Dropbox service? Now the sixth requirement is replication consistency. The replication consistency here is different than the consistency in the ACID requirement. What it means here is that when an update happens on a device, it will take some time to get replicated to the file storage service and also to other devices. And the replication consistency will be eventual. We cannot have a strong replication consistency here due to the nature of the problem. We are allowing offline updates to a file. So it means a user can actually update some file on a device which is offline. And then only when the device gets online, then the changes will get replicated to the file storage service, and from there it could go to other devices only when those devices are online as well. So the replication consistency will be eventual in case of Dropbox service. And please do not confuse the replication consistency with the consistency here in the ACID requirements. By the way, if you want more details on the requirements and the design of Dropbox service, you should check out my course. The link is in the description below. Now let's discuss some APIs that our service will expose. So the very first API is upload file. It takes user token, file metadata, and file content. The file content could be a stream of different chunks for the file. The upload file will return a file ID. Now there can be other APIs like update file metadata. It takes user token as input, file ID, and then file metadata. And what could be the file metadata is like file creation time, file updation time, file size, etc., etc. Another API could be update file. It takes user token as input, file ID, change metadata, and change segments or modified segments, changed segments. And this change segments is the input stream for all the different chunks or segments of the file that are changed. Similarly, we can have an API to delete the file, which will be delete file, user token, and file ID. A user can also list files. So there could be a list file API, this files API, which takes user token, root folder, page size, and page token. Another API is share file or folder, share file or folder, which takes user token, file or folder ID, another user ID, and set of permissions. And permissions can be read write or read only. Similarly, there can be an API for stop sharing, stop share, and it can take a user token and a namespace ID. So by the way, this namespace ID is the ID that is returned by the share file or folder function. The namespace is a concept I will discuss later. And of course, a user can always list all the shared namespaces. So list shared namespaces, so user token as input. And this returns all the shared namespaces for a user. Now let's discuss what a Dropbox namespace means. In order to explain what a Dropbox namespace is, I'm going to consider an example. Suppose we have two users, user A and user B. The user A has this root folder where it has file 1, file 4, and then it has a subfolder, folder 1, which has file 2 and file 3. The user B also has some file, let's say file 11, and then some folder 12, and then which has file 12 in it. Here, this collection of files and folders will be called as the user A root or home namespace. Similarly, this collection of files and folders is called user B home namespace. What is a namespace? A namespace is nothing but just a collection of files and folders with certain permission access. Now what happens is that this user A shares this file 4 with user B. Let's suppose this file 4 gets shared here. I'm just giving it a name, file 4 bar. So at that time, what happens is that this file 4, when the user A shared with user B, it moved from the home namespace to a shared namespace, and this file 4 bar here in user B is a proxy namespace that gets created when the user A shared the file here. So we have three types of namespaces. We have number 1 home namespace, number 2 shared namespace, and number 3 proxy namespace. So this was initially home namespace. When a user A shared a file with user B, we create a shared namespace for user A and a proxy namespace for user B, and this proxy namespace actually points to the shared namespace. You will find all the details about this in the chapter on the Dropbox service design in my course. Now let's discuss the overall high-level design of Dropbox service. So on my right side, we have a client application, and the client application itself comprises of 5 different components. We have a component called watcher. The watcher component in the client application is actually looking for all the file folder changes that are happening under the root folder that the user has specified to be shared with all the other devices and with the Dropbox service. Now we have a chunker. The chunker is a component that is responsible for breaking a file into multiple chunks, and it is also responsible for calculating the cryptographic hash for each chunk. So the cryptographic hash function that we can use could be SHA-256 or SHA-512. Then we have this file indexer. The file indexer actually stores an index of all the files which are stored within that root folder that the user has specified to the Dropbox service. And the internal database is a file database stored in the client app, where the indexer stores all the metadata information about the file and all its different chunks. The Dropbox client application can use any lightweight database like SQLite or Berkeley database, etc. for internal DB. Then the synchronizer component in the client application is the one which is responsible for syncing all the changes that happen on the device to the remote Dropbox service, or vice versa. You can find more details about these components and their design in my course, but there are some questions I would ask you here. The very first question is that we already decided, okay, we are going to divide every file into small chunks or segments, and the two reasons and the reason why we are doing that is that because we have two non-functional requirements that actually cause us to actually upload or download a file in the form of chunks. The question is, what would be the suitable chunk size? Should we use 4 kilobyte, 8 kilobyte, 64 kilobyte, 1 MB, 4 MB, 64 MB? What do you think? What would be the most suitable chunk size, and how to calculate an optimal chunk size for a file? So this was the client application, and if you see, the client application is communicating with the Dropbox service over the internet. And now these are different microservices within the Dropbox service. We have a gateway service, we have a synchronization service, we have file and folder metadata service, we have a user and devices, we have notification, we have object storage service, we have block service or a chunk service, and we have billing service. I'm not going to details of the design of the gateway service. If you see my previous videos on designing Uber, you will find details there. The user and devices actually store information about the user and all the devices that the user has. The file and folder metadata service actually store all the information, all the metadata information about a file, and it also stores the information about if a file is shared with multiple users, then that sharing information is also stored in the file metadata service. The synchronization service is basically a service which is the main component which is talking with the synchronizer here in the client application. Any changes that happens on a device, the synchronizer informs those changes to synchronization service, and then from there, synchronization service, the changes are stored in the block service and object storage service, and then in the file metadata service for a file. So whenever a new file gets created, the information is stored here in the file metadata service. Similarly, when a file gets shared with another user, then the information gets added here in the file folder metadata service. And similarly, other user devices, if they are running and they are online, the synchronizer component in the client app communicates with the synchronization service to receive all the changes that has been done on different files under the user namespace or the shared namespace which the device is subscribed to. And the synchronizer then talks with the synchronization service to get all those updates. If you check the online sources, I think none of them has discussed what would be the internal design of these services, what are the different database schemas used by these services. You can find that information in more detail in my course. And now if you go and check my course, you will find that there are multiple ways to store file metadata information. And I have discussed all those different approaches, and I have also discussed all the pros and cons of those approaches. And this is very, very important. If you are applying for an L5, L6 or senior principal level engineer job, what the interviewer is looking at is different trade-offs. The interviewer doesn't ask you to just design a system and just give you one design approach and that's it. He actually loves if you provide multiple approaches and you can discuss the pros and cons of different approaches. And then based on that, you decide which approach is better. So for example, there are multiple ways to design the file metadata database schema. I'm not going to details right now, and either you can check it in my course, or if you want, you can Google it about different approaches to store the file metadata information. The first approach is adjacency list model using the parent reference. The second approach is adjacency list model with the children list. The third approach is materialized path. And the fourth approach is nested sets model. You can get details of those models either in my course, or if you want you can Google it and see what it looks like. But of course in my course I'm also defining all these schemas based on different approaches. Now there are some questions that arises, like if you are using one approach to design the file metadata, then how the file sharing will actually happen in case of that approach as compared to if you use a different approach to design the metadata. Or for example, if a user wants to stop sharing files or folders with other users, then what needs to be done and what are the changes that needs to be done in the metadata service in that case. And now as far as the block service is concerned, this is a block or chunk service. This actually stores the metadata information about each chunk. Of course the chunks itself are stored in the object storage, but we actually store the chunk metadata information in the block service or the chunk service. This block service is also responsible for generating different version information for different files, and in the course you will find the details about two approaches that we can use to generate versions or snapshots of each file. In the video I haven't discussed the design of the synchronization service in detail, but let me tell you that it comprises of some app servers and of course some distributed queues, for example Kafka, and some agents that are listening on those queues. And so what happens now, whenever a user creates a file, the synchronizer actually informs the synchronization service, or actually the app servers here, about file creation. The request goes to one of the app servers. The app server actually calls into the file metadata service to create the entry for that file with the status pending. After that, all the file chunks are uploaded, and whenever a chunk gets uploaded to object storage, the metadata information for that chunk is also get added here in the block service. And then once all the chunks are uploaded, we actually go and change the status of pending to uploaded in the file metadata for the file. Similarly, when a file gets updated, the synchronizer only uploads the chunks that are modified. Those are written into the object storage, and then the synchronization service calls into the block service to also insert the new entries for those modified chunks. Similarly, when a file gets deleted, the synchronizer informs the synchronization service, and then the synchronization service actually go and mark the file as deleted in the file metadata, and then of course we run a workflow in the background that actually goes and delete all the different chunks of that file from the block service and the object storage. So the main point I like to convey here in this video is that the very first important thing is always come up with the functional and non-functional requirements. Once you have discussed the functional and non-functional requirements with the interviewer, then you have to of course design the system based on those requirements. And it is always better to design the system in terms of different microservices. You see, I'm not putting any load balancer here because right now these are just logical diagrams for different microservices. What I would like to say is that do not try to design a system as a monolithic service in an interview. Always design the service in terms of different microservices, and you can go deep into the design of these components individually later on. And that's why you are not showing load balancer here right now in the design. But of course, each service will have some app servers behind some load balancer. I hope that you must have found some information very useful in this video. And if you find that video useful, please do like the video and please do comment below as well. And please do subscribe to my channel. There will be more videos coming soon. Thank you and take care.